Okay, we should be live. Hi everyone, welcome to ACDC. This is call 138. I just put the agenda there in the chat. And yeah, let's go ahead and get into it today. So, first, Electra. We just launched devnet 1 a few days ago. Very exciting. I wonder if there are any updates with the latest there. Last I looked, it looked like participation was quite low, and there were a few forks of the chain, so not looking super great. Anyone here have any more to share?
Yeah, maybe I can give a short update. So Philip set up the network earlier on Tuesday, and I think Aragon had some issues around Epoch 64 and haven't been participating since, but I think the team is aware and are looking into it. And then some external users started sending transactions some point around slot 1800 or so. And then the chain forked into about three parts. And then it looks like there's an EIP 7702 transaction that caused a split, but we haven't been able to fully debug it. Netherman and Bezu seems to be building a consistent chain. Reth and Geth seems to be consistent in their chain, but these two chains have a lot of forking and reorging amongst themselves, and Ethereum JS pairs are not proposing since a while. So yeah, I think that's the latest status, but yeah, I'm just getting caught up as well.
Cool, thanks. So yeah, sounds like there's some fun debugging on the horizon. Yeah, nice work though. It's exciting to see devnet 1 up, and yeah, we'll just keep iterating from here. Anything else to say there? It sounds like, yeah, clients are busy figuring out what's going on with the devnet.
Yeah, in case client teams need something for debugging, please text on the interop chat, and we're happy to help get you whatever you need.
Cool, thank you. Okay, we can move on to the next item then. Let's see, this is from POTUS. And essentially, I mean, maybe he can chime in a bit more, but it sounds like a suggestion to move some of these request data that we're introducing in Pectra outside the execution payload type in the beacon chain in the CL broadly. And yeah, it sounds like there are some reasons to do this. Is POTUS on the call? Let's see. It looks like you're here. Would you like to
I'm
give us a summary?
sorry, I just logged in. It seems that on time. Are you talking about this the issue of the execution payload and a container?
Right, and the request. Yep.
Okay, good. So let me quickly describe the issue. Since Bellatrix, since Shanghai, the beacon block contains inside its beacon block body the full execution payload that the block itself is broadcast and is transferred on the P2P layer for the consensus clients. And the consensus client gets this payload, it sends it to the EL for verification. Capella introduced a new thing, which is that the fact that the payload has withdrawals that were honored in that payload on the execution layer. And at the same time, these withdrawals needed to access the beacon chain, the beacon state, to honor the deduction of those balances from the beacon state. So this was the first time where we actually had to synchronize information that was happening, some state transition that was happening on both layers at the same time. However, since Bellatrix, and this was not modified in Capella, the consensus clients would get this full block, would send the payload for the execution layer for validation, and then they would completely forget about this payload. They will save in their DB, in the database, will save the full block minus that payload, because that payload anyways is being saved in the execution layer database. In Capella, when we added these withdrawals, in principle, we could have saved the payload. I'm sorry, not the payload, but the withdrawals part of the payload. But since the withdrawals are deterministic from the beacon state, this didn't present any problem. You could grab a very old beacon state, a very old block without the payload, and you can perform the beacon state transition function without ever getting the payload. Electra changes this. In Electra, the execution payload is needed on the consensus layer to perform the state transition, because the requests that are included in the execution payload are needed as input. These are external inputs to the beacon state transition function in the consensus layer. This was, again, I repeat, this is not the case for withdrawals, even though withdrawals are in the execution payload, because the beacon state already knows what withdrawals should have been in the payload. So what I am proposing, this presents a problem now for consensus clients, because consensus clients oftentimes have an old state, have an old beacon block, and they want to perform the state transition to get the new state. In the current status, either the consensus client saves this information in whatever schema for the database they want to do. This information meaning the Electra fields, there are new fields that the consensus client requires to perform the state transition function, or they don't save it. They send the payload, as we do now, to the execution client, and then later on, when we need to perform the state transition, we request the payload again. This makes it very inefficient, and clients will not catch up if they need to sync a block that requires these old state transition functions. So my proposal is to transform the way that the consensus, two changes. One is on the consensus side, the structure of the beacon block body. Another is in the engine API, the structure of the message that is exchanged between the consensus client and the execution client. What I'm proposing is that the beacon block body on the consensus layer contains an envelope. In this envelope, you find these fields that are required for the state transition on the consensus side, this meaning the requests, and a payload, the execution payload. But this execution payload doesn't include, again, these same fields. So this means that the consensus client would be able to hash the payload and just blind it and just save that. This will make it compatible, forward compatible with SSZ when the execution clients move to SSZ, because then the hash that we're going to keep for the payload would be the actual hash for the block if eventually the consensus client moved to SSZ. On the engine, we will need this change that the calls for get new payload and the calls to inform that to notify a new payload would send this full envelope, and then the execution client will need to add these fields from the container to the payload to compute the block hash. So that's I hope that it was clear what the problem is.
One clarification here. As far as I understand, you don't drop the entire payload. You just keep the payload header anyway. Otherwise, you will, actually chatting about this in the chat. I mean, yeah.
I'm gonna have to read that chat.
Yeah, so this is because you have to serve requests from other peers to get the full block, and you can use get payload bodies to get transactions and withdrawals if you need withdrawals from EL, but the header should be kept in the database.
Yeah, that's right. We keep the header, right? And then today, the issue is that through P2P requests, we only request from the EL through P2P. But for state transition, we're okay. But for Electra, now we also have to request from the EL just for state transition, and we are worried about the performance penalty here.
Yeah, sure. So let's just imagine if we don't have this envelope at all. So what then would you have to do in the database? Would you need to introduce execution payload without transactions?
You would need whatever you do, because these clients would handle this in a different way, each client. But whatever you do, the consensus client will need to save in the database in whatever schema these new fields, these requests.
Yeah, so like usually you have just the header and you don't need any of the objects that go along with it because you have usually you only need the root of these requests, but now you need actually the requests. And usually we're just storing the header. So we'd have to have either some sidecar pattern, which makes the code quite unaesthetic. But yeah, you'd have to store it on the consensus side or request it from the EL every time you want to do a state transition.
Exactly.
Which is very ugly.
That's the point. Yes. And it seems to me that the change of just the changing the structure into an envelope, it's a very simple change.
Right. Yeah. Oh, go ahead, Mikhail.
Yeah, I have another question. So you've mentioned that whenever you validate the payload, you then drop the transactions from it. So it happens even for non-finalized blocks, right?
Correct.
Okay, I see. I didn't realize it was quite aggressive as that. Yeah, but makes sense. Because you don't. Yeah.
The whole reason we have the payload bodies method is so that the CLs can drop the bodies and just have the headers. But
yeah,
this
for sure. That. Yeah, for sure. I was just, kind of like under impression that it happens for the finalized prefix of the chain. So if it happens for every payload, then I see initial problem. Okay. So what if clients introduce execution payload without transactions? I know it sounds ugly, but would that solve the problem? So you can just.
I think it's not. So it's the other way around. For me, the problem is not about transactions or not. The problem is about what information each client needs to perform their state transition. So anything that the consensus layer actually needs to perform its state transition should not be at the same tree level as a Z tree level from things that the consensus layer does not need. So anything that we do not need, if we keep it one level below in the hash tree, we can just hash that thing, keep the hash of this, and only save the objects that we need that the total hash tree root would be the same.
Yes, I can understand that, but as far you have this header anyway, so it's like header plus 2 new fields with requests that are introduced, maybe more in the future.
Like if we don't change this on the P2P layer and we just try to do it internally, which we can kind of, but the problem is you'd have this extra object that has the extra information that you need, but it needs to hash to the object without the extra information. Yes, because that's not on the, that's not in the specs. So like that turns into something really ugly where like the thing you get from the network is different than the thing that's not complete. I don't know, the ways around that are quite difficult to deal with.
Right.
But also, Misha, why is it that, what worries you about having this in an envelope? The envelope comes with the block itself. So what is the pushback against having an envelope?
Yeah, I'm just trying to understand how big the problem is. I'm not against this change. It's just, we used to have the execution payload representing all the fields and containing all the fields that are required to recreate the execution layer block. Now we want to break this. No,
I do not want to break this. The envelope, call the envelope payload if you wish. From the point of view of the EL will get the envelope, not only the payload. The EL gets the envelope. And if they want to hash it as a Z, they can just hash it immediately. If they want to hash it as RLP, they need to move the requests alongside the rest of the fields and then hash it.
Yeah, I see. I can understand that. Okay. Okay. If I would say that if this problem is common to all CL clients, then we should probably, do the change, or this is the change to the API, and EL clients will need to change this.
Yeah, I don't.
It's not only the API. I'm proposing that the beacon block body structure changes.
Yes, that's correct. I see. Because we kind of already have the envelope, right, which is called execution payload now, and we need one another abstraction level here.
That's correct.
So yeah, I understand that, but let me think on it. Could you please, I don't know, could you please outline this in the
There,
issue?
I mean, I pasted it in the chat, but yeah, that I don't think the actual proposal has been like laid out somewhere other than maybe in Discord. But yeah, I pasted it from what POTUS had sent me. That is just a
I can
small
open a CL repo issue because anyways, this pattern is already used in my PR for EIP 7732 because then it's mandatory to have the envelope. So it's just repeating what we already do on EPBX.
We also need changes for the engine API as well. I presume the CO issue will also talk about engine API changes.
Yeah, we would need those. This is why I just want to see the proposal so we can discuss it there synchronously.
Yeah, I think it needs more discussion and a proper proposal, but yeah, I think it's good so far from what I've seen because we didn't have a way of dealing with this either that was at all.
Yeah.
I know the problem that he's talking about, and it was something that was missed in DevNet 0 because technically MEV Boost is broken right now on every client. If you test MEV Boost with the transactions that are in Electra, we just haven't tested it, but we would find that if we did. And this is the problem that awaits us.
Right, but I just want to mention that fixing Math Boost does not sound like an appealing argument for me to make a change to the core protocol structure.
Whether it's broken because of this problem, whether Math Boost is there or not.
Yeah, and actually this proposal can help to solve this problem. Like it will introduce a structure that could be used by MEV Boost and will be kind of but anyway, Math Boost could be fixed without this by introducing the same structure in the builder API level, right?
Yeah. Technically, this issue is actually just caused by the fact that we dropped the payloads, but it arose. It was easy to see with MEV Boost. Anyway.
Yeah, got it.
Okay, so to summarize, the CLs prune the EL data because generally they can, but given the way that we have these request structures in Pectra, this is no longer sufficient. I think that makes sense. The suggestion is to essentially solve this at the type level, if only just to make it sort of clean, to still drop the payloads while having the request data you need for the state transition at the CL. Yeah, I mean, when I first saw this, I was thinking like you could just pull out the request and just put them, say, in the DB next to the payload, or rather the block. But it sounds like everyone would much prefer this actual sort of, more specific SSD structure. Does that sound right?
Yeah,
That's
because
what
it
I'm
all
hearing.
just comes down to the difficulty of having something that has extra information that doesn't get hashed in. That not having to do that makes it way easier.
Right. Okay. Yeah, POTUS, if you don't mind opening an issue, I think that's a good next step here.
Already
And
typing it. I'll paste it here before the end of call.
perfect.
Yeah, great.
Thank you.
A little bit, yeah, sorry. One more thing. A little bit of pushback that I have is that we are trying to solve implementation complexity with changes to the protocol, which are just, not necessary for the protocol itself. It's probably why I have a kind of like a pushback on it and want to think more.
Yeah, but I would argue the other way around. I would argue that the current design is just philosophically wrong. The current design mixes in the same level, in the same message, data that is needed on the CL for the state transition that is purely on the CL side with data that is not needed in the CL at all. So I would say that the current design is just wrong and we're trying to fix that mistake.
Right, it's not wrong. I would say it has just different philosophy because it has all data that are comprised in the EL block, and that's it. That's the basic stuff that we had before. But yeah, I completely understand your argument.
And the other reason that we didn't run into this with the versioned hashes was that we put those in the CL block. But they technically came from the execution layer. And so yeah, it's what POTUS said. Like they removed one layer higher in the tree. And so it worked out nicely. But since we'll presumably be adding more cross ELCL transactions in the future, we should have them at the correct level.
Yeah, that's interesting. Maybe maybe we can really, as Gajinder suggested, just have those requests in beacon block body and send them.
Yeah, that other proposal that you made on the engine API of moving everything into the beacon block body would have also worked, but it does have those corner cases around new payload. But
right, but those corner cases.
That as well.
You mean like those that are related to optimistic sync edge cases?
Yeah. Yep. In not sending new payload for every payload. That is the only reason that we found, at least, that not to do that. But this is actually a strong argument to do that if we don't do what POTUS is saying.
Yes, but
I don't actually think that there is a problem in optimistic sync, because when CL sends an FCU, basically you construct the chain based upon a trusted latest root. So basically the entire chain before that is all trusted, and when you are sending in new payloads, then you obviously are sending the data for that particular root to be verified. So I mean, I don't really see it as an issue with respect to optimistic sync.
Yes, I agree with that. So as long as EL block has all the data to sync, and to verify, we are not removing these requests from EL block. We just sending these requests to EL in a different way. So it should work. They will be checked by the block hash anyway.
Okay, yeah, I will echo what Mikhail's saying. Like, it seems like there are a couple different ways to solve this. POTUS has one solution. Yeah, so I think if we get something written, then we can continue the conversation there. Anything else on this topic? Okay, cool. Next up, we had an item for an engine API update. This is from Light Client for devnet 2. I haven't had a chance to look into this in detail. Let's see. Light Client.
And I think this is similar to this question that we've been talking about.
Okay.
So I don't know if we can really make a decision before we decide where the requests actually need to live.
Okay, that would influence this PR you have here.
I mean, I guess like you could still have the request encoded in a similar way, but it sounds like we're probably going to have some sort of. Are people wanting to do this like union of requests, or will we still keep them separated at the CL?
Generally, it makes it easier to deserialize when they're touching something, but I can't say for sure.
Basically, I'm proposing that over the engine API, the requests are sent as an array of the requests as a request object, not like the individual type. Because right now on the EL, we're converting the list of requests that exists in the EL block into individual lists of individual request types. Unfortunately, this adds some requirements to the EL to understand from just a individual block whether a request type is enabled or not. Because if I just give you an EL block and there's no request of a certain type, and we've added like, we're 3 or 4 forks down the road and we've added some more types of requests, like you can't tell just from the block anymore if the request is enabled or if there's just no request for that block. And so I think it makes the engine API on the execution layer side a bit more annoying. So I'm basically proposing that we send over the request object as it is on the EL. And if on the CL you use the union of that, then that would kind of directly pipe into that data structure. If you are separating them out, then you would be able to just separate them by reading the list of typed requests and deserializing them into the list that they should go to.
Okay, so this is related, but it sounds like we'd still possibly want to do something like this, even if we end up changing the structure on the CL.
I think they're related, but yeah, it can be done either way for wherever it lives on the CL.
Right. So yeah, I mean, we
So
have
my
this cross
proposal
layer,
is
yeah.
my proposal is for the requests to come through as a single list of all of the requests, and for the type of request to be identified by the type JSON field, just as it is with typed transactions currently.
Yeah, that makes sense. Right. Like we have these set of cross-layer features, and we need to figure out exactly where the boundary is across EL, Engine API, and CL. That makes sense. POTUS, you have your hand up?
Yeah, so I mean, these problems are related, but they seem to address a different area, different problem itself, which is we currently have a type on the CL, a type on the EL, and then we have these messages that are being exchanged on the engine API. What my proposal was about the type on the CL, and this doesn't contradict Matt's proposal. I would still suggest that the type on the CL has this level structure, and then we put in that on what level the requests, and these requests can be a list of requests, can be a union, can be separated, I don't care. On the EL side, it seems from what Matt says that it would be better to have the type one request object, which is a list of unions which may have different type of requests, a list of lists. This would be fine as long as the engine API puts them at a different level. This already solves my problem. And then the object that goes in the level up, we could handle it. Either the EL has the problem of trying to interpret it and separate them, or the CL has the problem of trying to interpret and separate them. It seems from what Matt is saying that it's better for them if the CL interprets them and separates them in different objects. That's fine by me. Well, we already need to know what those objects are, so I don't see any problem with what Matt is suggesting into putting out on the envelope one object, which is the requests.
Yeah, that makes sense.
Yeah, one of the affiliate arguments that Light Client made is like let's just have on the API level the data structure that maps on the core data structure to avoid potential edge cases in the future. One, I don't know if it's a problem or not, but now CL will have to, if this proposal accepted, CL will have to kind of handle request mapping from different lists to just one, but it does not seem like a big surface for bugs, and those bugs can be found easily.
I think it's just that the different types have to be, I think, carefully thought of if we have different kinds of requests such that it's not ambiguous on which kind it's deserialized into. And you
Well,
can
the
run into
the type field should disambiguate what type to deserialize into. So even if some fields are reused across different types, then you can just look at what that type value is and then put them into the correct SSE object.
Okay. So there's a byte, or is there something that marks it? You said a type value?
Yeah, I mean, it's the same as how we represent transactions over the RPC. So if you request a block with transaction values filled in, then you'll get a list of the transactions, and the fields are sort of reused in this like generic transaction, but there's a type field that says whether it's type 1 transaction, type 2 transaction, type 3, whatever, and then you can use that to differentiate. So that way you don't have to just like look at the fields and infer based on the presence or non-presence.
Yeah, as long as we got something like that, I think we'll be fine.
Okay.
Terrence?
I guess one thing to note is that when we get payload as a proposer, that we also have to parse this request on the CL side, right? Because we have to put those on the envelope or become block body ourselves. Depends on what the decision is.
Small comment here. I believe that CL, while sending those requests to EL, may not respect the order of those requests by type as it is in the EIP. I guess this is true.
I don't
Or
recall
should
this.
you-
Yeah, I don't
or should
recall if
you-
there's an order on the spec.
I mean, the order should be inferred just from the engine API message. So as you're pulling out the values, you can just keep it in order, and the EL would have placed it in the order that it was already on the execution layer.
Right, but is
Yes.
it sorted by the type byte?
It would be sorted by the type byte, and then intra type byte, like each proposal has a different way of ordering, and the EL will have already ordered all of that. So as long as you take it from the engine API and interpret it as it's ordered from the engine API, it should be the same.
Right. Does that address your concern, Mikhail?
I was just just thinking that CL should respect this order or not. Yeah, but that's a detail. Maybe not worth talking about it.
Well, the order is important. At least, yeah,
Right.
intra-type. Yeah, so definitely should go in the same order as given.
I'm wondering, like, what is the simplification on the EL side here?
When the EL converts the block into an engine API message, it doesn't know from the block data how to fill out the presence or emptiness of a request. because in the request object on the EL, it's a list of typed values. And so if in a future fork we add another request type, then I can't tell from the block itself whether that request type is empty or if we haven't activated that request type yet on a fork. So propagating that information in is not that simple. We can do it, but it's kind of weird for us to represent on the engine API this data in a different way than it's represented on the execution layer. I think that this is just like a much better simplification, and the CL can much more easily differentiate whether the request is empty or whether the app fork is not active.
Wait, you don't know what fork you're in, or what the fork the block was in?
Yeah, I mean, usually we don't plumb the fork information through every code path in the engine API. It's kind of at the top level of verifying like the method that's coming in. But then when we're dealing with the block itself, the block doesn't have the concept of this is a Bellatrix block. Like on the CL, I think you guys are very good about separating the different types of fork blocks from each other. But on the EL, I think this is how pretty much all clients have implemented it. We have one block that represents all of the block types, and we use the presence, like the nullness of a value, to sort of determine if that thing is active. And so this is, again, like part of the reason why requests were added in the first place in this format, was to take advantage of how ELs have been built historically. And this is just a continuation of trying to avoid re-architecting a lot of the client or doing things that might be like bug prone just to represent things in a certain way on the engine API.
Okay, but fundamentally, this is a fragile heuristic. The idea of, and I don't think this goes against anything you're saying, but the idea of checking for the presence or absence of specific fields. Well, we in Nimbus do it for certain things too, unfortunately, because yeah, we have to. But that is one of the worst parts of reading certain of these JSON objects, because it is a heuristic. And I would say doubling down on that is maybe not super great.
Yeah, I mean, we're like 12 forks into this design, so it's a little bit difficult to just like turn the ship around and change how we have architect the block. So I agree it's fragile, but I don't really know if there's much that can be done at this point, unless some ELs also agree that they want to like sit down and change the way that they represent the block. It seems like this is not a difficult modification to the engine API and makes things simpler for all of the ELs.
Can you not infer which fork you're in from the engine API method version?
I mean, you kind of can, but
like that, those are decoupled.
Well, I think now they're sort of coupled again. Like now we're pretty strict about checking what fork the person is requesting. So if you call like fork choice updated v4 with a non prog block, I think it should return error. So I think that you can kind of infer now.
I think we do. Oh, fork choice updated v4. I'm not sure. I have to check.
No, with the parameters, like you can't build. I don't think you can build a Cancun block with fork choice updated v4. I might be wrong on that, but nevertheless, propagating this information down into like our block type is different. I mean, if other execution clients don't have this problem at all, or think doesn't make any sense, then maybe I can go look at it some more and figure out. But I think that this is the case for a lot of different teams.
why
Right,
is
I
it?
mean-
Why do we really need to care about typing here on the API? Why would it be? It sounds from what you're saying, Matt, that it would be fine for you if we send you, for example, a list of lists which are just interpreted as raw bytes, and then you make the interpretation and change into your internal type, and we constructed that list from our internal type. Would that
Well,
work?
then you would need, well, if you send a list of bytes, then we would need to figure out what the byte structure is, and then it would have to probably be RLP because we haven't done SSE yet. So it's like you have to interpret the data, like the actual data, not just the bytes. So it's different from the transaction data.
So then probably it might be an issue for us because I don't think we have unions correctly implemented in SSE.
I mean, you don't have to implement SSE unions. I'm just saying that if you happen to implement the SSE union, then this format would map very closely to what the union, like you can still during deserialization of the engine API message determine where in like the individual fields, like the list of withdrawal requests, the list of consolidation requests, where those requests should go from that message. That's not a problem. I'm just saying,
Okay,
like,
that's
if you
fine then.
wanted to have, if
Okay,
there
so
was a
so you
desire,
wouldn't be against like we keeping them separated in our internal type, like the
I don't
beacon type, we
really,
keep them
yeah.
separate. Okay, perfect.
It's not for me to say, like, whatever you feel is right on the CL. I just think over the API, it's simpler for ELs to just send what the block data already is, rather than doing some interpolation of the block data and combining some fork logic. Like, we can do it, don't get me
correct to
wrong.
me. No, that
Yeah.
sounds correct to me. It's fine. It's just moving the interpretation that seems to be easy on our side.
Yeah, that was my take.
Just to we do call like new payload and get payload v4 before the fork, and I haven't seen any errors from any, like, I mean, we're running devnet 1, it's fine. And I'm pretty sure the API was designed that way. That's why these fields are nullable in the first place, because they have to be null before the fork. So we've decoupled those. I think they're still decoupled.
At least the spec requires the opposite, so the errors should increase.
I mean, yeah, it says engine new payload v4 spec. The client must return unsupported fork if the timestamp of the payload does not fall within the time frame of the prog fork. So if you're calling new payload v4 before prog, technically, that's should return an error.
Okay. Yeah, Mark. You have something to say?
No,
Same with get payload. So I don't know.
Right. I mean,
We may not be implementing it that correctly, but that is like the letter of the spec, I think.
In any case, it sounds like this would be helpful to ELs, and CLs have liberty to kind of just take the data and then do what they would like with it. So I think it makes sense. From here, I think, yeah, so we have this PR, and then the other issue we will iterate on, and then, yeah, I think just having them all together is the next step, and then, yeah, we can go from there. But generally, it sounds like both of these seem like directions moving. Any other comments on this? Otherwise, we will move to stable
I guess I'll
containers.
just say that.
Go ahead.
That what this does make a certain style of JSON decoding a little more a little trickier, let's say. So right now, Nimbus does the best it can to decode JSON it receives according to as strict a schema as the specs sort of support in each case. And these variant types just utterly rake this. I mean, we can't. we can then do all the usual, we read it and figure which type it is, we tap out to a new object. I assume, I don't think there's any realistic alternatives. This is what JSON supports because it's not ordered. But it's a mess no matter how it happens. So, I mean, as long as people are basically just upfront that it is not particularly less messy for CLs to do this than for ELs to do this, that's fine. This is just a move of complexity and messiness from the EL to the CL, and it's feasible either place. But it does not, moving it to the CL does not solve this problem. Let's say, is maybe how I'll frame it. It just moves it.
Sure, but then CL clients, I think, are more equipped with just the types they have at hand to handle the problem. So this does seem like the direction to move in to me. Okay. Next up, Eton has an update on SSC and stable containers. Essentially, he's asking if we want this in devnet too. There's a link to the IPs. Here, let me just grab a link to this. There's a very nice comment here on the agenda. So yeah, link to the IPs, specs here, test, and then I believe this is a link to Kurtosis network they have running. So yeah, that's all super exciting to see. The question is if we put it in devnet 2 or not. Just like process-wise, generally we would formally include these things into the fork, and then devnet would be downstream of that. So if we want to consider SSZ and the stable container update for Pectra, that's a conversation we will have to have. Maybe I'll just pause there. So how do we feel about including these EIPs? Well, okay, actually, maybe Eton, is there anything else you'd like to add before we get into that?
Yeah, I have minimized the EIPs to the minimum. Like that, I think we should put in Electra because we have this opportunity now because beacon state reaches a new power of 2 number of fields, so gets re-indexed. So if we don't do this change now, then like Rocket Pool mainly, but also other staking pools will have to do yet another redeployment of their contracts every time that this happens again, and also when we would introduce this table later on. So this, what's in this PR today, it does not have SSC transactions or any of the other SSC stuff. I think that the other stuff like SSC transactions can be moved later down into Verkle so that the Verkle fork is the one that changes data types more strictly. But we still can do the CL only changes today so that EIP 4788 becomes practically useful. I have also obtained support from Rocket Pool. I just linked it, this Discord link where they support this EIP. And I can also obtain more similar statements from other staking pools if that's required. So yeah, the PR consensus specs is linked in the comment that Stokes linked. And I have also generated consensus spec tests.
Cool. Right. Let's see. I think if I'm interpreting correctly, there are some clients, Teku here, Lodestar, who are saying +1 for the SSE feature. Any other clients want to chime in?
I'll say for Prism, we were ready to say let's try devnet 2, but I think including in specs, like merging into Pectra is more of a surprise. So I don't know if the rest of the team wants more time to consider that.
Well, I think that's what it would mean.
Yeah, DevNet 2 is Pectra DevNet 2, right?
I think he was. Did you mean that Prism is ready for DevNet 2, but if we add stable containers, it would take longer?
Oh, sorry, no, I meant that. I guess like there's. I thought it was more experimental, like a finality of inclusion. But yeah. So I haven't synced with the rest of the team on it, but yeah, I think we can do DevNet 2. So I don't know if there's opposition to including stable containers for any other reason, but I'll say from an implementation side, like we're working on it on track.
Right. I mean, I think the obvious thing is just that Pectra is incredibly large already. I mean, especially if we end up with Pyrdos in the fork. So, at a certain point, we do need to be very realistic about how big the fork is and the risk that entails for actually shipping this thing. Again, I agree with the justifications Eton gave around this feature being valuable in a vacuum. That being said, this is, I think, the biggest hard fork or one of the biggest that we've ever done. And that should not be taken lightly. Perry had another comment here in the chat that essentially, okay, maybe an EL person can help me here, but it sounds like EOF is in Pectra, but it hasn't, been on a DevNet yet. And so that's all well and good. But then what that would mean then is, yeah, it's like also another really big change. And again, just looking at DevNet 1 today, it doesn't seem like DevNet 1 is going super well. So I do want to caution against kind of, biting off more than we can digest, so to speak.
At the risk of saying something wrong, I believe the CL, I mean, this is a CL change, and CL has less stuff than the EL at this point, I think. But
Well, right, but
I only partially agree with that. I think Pyrdos is still a massive change, and there are a lot of shared resources between EL and CL. For example, we have combined testing teams. And I do think at some point we have to get realistic that we can't just have every EIP in and at the same time just keep increasing the scope. There is a bottleneck.
A very real one. Okay, I mean, unless someone wants to make a very strong case here right now, I would suggest the following. Let's work through DevNet 1. And then I would even say wait on DevNet 2. And we can reconsider this in the future. But again,
But one point I do want to make, would adding SSE to a DevNet actually change anything? Like, for example, we have SSE DevNets. So don't we kind of have all the data we need to decide if SSE goes into Pectra or not? And once we decide if it goes into Pectra or not, then we can talk about DevNet scheduling. To me, that sounds like the workflow we kind of need to have. So the question right now is not when SSE or stable containers is in a DevNet, but rather should it go into Pectra or not? And what data do we need to make that decision?
Right.
So I feel like an important part is understanding like how big of a pain breaking Merkle proofs is for app layer teams. We definitely I've heard from like smart contract auditors at Sigma Prime about how this impacts their clients and like they're avoiding bugs I guess kind of narrowly by like realizing an upcoming fork is gonna break their contracts. So that's like an anecdote that I can speak to. But if it's like easily telegraphed that we're gonna break proofs for beacon states in Pectra and then like once more for stable containers and that's it. Like how much worse is that than just having like stable containers in Pectra? So pretty much app layer input, I feel like is really important in deciding this one. As far as like work for client teams. In Lighthouse, we have like a pretty far along implementation. The changes in the client code isn't very large. It's more impactful on the SSC libraries, obviously, but I don't think it's like crazy. Definitely sympathetic to the fact that the fork's very big, and I want to include PeerDAS, so would definitely lean towards like would rather PeerDAS and not stable containers if I were to choose, but it's also like they're not really weighted equally. Like stable containers is definitely smaller than PeerDAS.
Would also on
In
that
that case,
on that point about messaging, like they're also uh, app developers are trying to develop apps, so knowing sooner rather than later, or telegraphing sooner rather than later is also helpful to them because they know what they can build now and get audited now.
would
Sure.
that mean if we have like a public SLC devnet, would that allow app devs to play around with it enough to know what breaks or not breaks? Or does it need to be Pectra plus SLC for them to actually get this data?
They actually just want to know what's in the fork because they've been bugging us about, I mean, just an example like eigenlayers. They're trying to get their things audited and they've been bugging us about whether or not the fields that are in the beacon state for Pectra right now are likely to be the final fields that are in the beacon state. But that question is irrelevant if we don't know whether or not we're putting in stable containers. So it's more like what Sean said, like it's about knowing what the real schedule is for when what is going in what fork. That makes it easier on them.
Sure, but like we can tell that, you could look at Vector today without the stable containers and you would know, right? Like, I don't, just from what you said, it doesn't seem like they're asking about, oh, will this be stable forever? They just want to know what to target for the fork.
I think so, yeah.
All right. Enrico?
Yeah, just want to add that. So what's been targeted for being included in Electra is a, let's say, simplified version of stable container implementation, which does not cover all the full spec that is in the stable container EIP. So it's also possible that the client team could implement the quick version to just enable stable container and then have the full implementation for next forks.
So basically, the CLs would like to have it included in Pectra, have a public devnet so that app devs can give them feedback and then decide if it's actually included in Pectra. Is that kind of the workflow I'm getting?
Well, they can get public feedback from, as I said, SSZ devnets, right? Like it sounds like what has been surfaced on this call, at least, is like these applications just want to know what's in Pectra, not necessarily that this, XYZ are in Pectra and that it will be stable forever. These are two different things.
Well, so I personally don't know which of those is true. So like it could be that application teams actually really hate these like Merkle proof breaks. That could be true. It's
No,
more that like
I'm
I
sure they
feel
don't
like
like them.
yeah, I feel like we just need more input from there and like maybe other teams have other input for like um from application layer devs they interact with, but I personally like I don't know how critical this is.
Hmm. I mean, do other CL teams feel that it would not be disastrous to increase spectroscope beyond what it already is? Like, do you not feel that it's already quite big? Okay. It sounds like then maybe we'll take some time to think about that. And then how can we move forward? So, yeah, again, unless someone feels the pressing need to make a decision right now, it sounds like we can decide in the future. Again, I think we should focus on DevNet 1 for the time being. In the meantime, I think we should get more information from app developers to the extent we can. And yeah, I would recommend each CL team to think very seriously, again, about like Pectra scope and what that means for a successful hard fork. Every EIP we add is just going to, add more code, more risk for bugs, generally complicate testing, and all of the usual bucket of things. Eton?
One thing I'm wondering about PeerDAS is its CL spec. I think right now it has an optional in there, so I'm not sure if that one is still there. But if it's there, it's sort of that's a dependency there, because if the PeerDAS is activated before optionals become a thing, then that design needs to change as well.
Right.
But
I don't recall an
yeah,
optional. Anyone else?
I can look.
Yeah. I guess we should go take a look. I don't recall there being one. Generally, we avoid them, again, because there's limited support in SSE libraries for them. Okay. I think I'm going to call it on that one. I do think we have a few things we can do to get a clear picture of SSE. But again, I will just call out yet again. Think very carefully with your client team, again, about Pectra scope. I know that, hard forks come very infrequently, and so it's tempting to try and get as much in as we can. But at the same time, if it's if there was a problem rolling out a hard fork, that would be worse than waiting another fork or two for whichever feature we have under consideration. Okay, thank you. Yeah, Eton followed up. It's actually a Verkle usage of optional and not PeerDAS. Okay. And speaking of, that was the next item on the agenda. Guillaume? Guillaume, I can't hear you if you're speaking, but it looks like you unmuted.
Oh, can you hear me now?
Yeah, you're good.
Okay. Yeah, I was just going to say, don't get out of your way to support optionals just for Verkle, because we're currently looking at other options. We would still like to have it, but yeah, it's not the end of the world for us if it's not there.
Okay, good to know. I think we're early enough in the Verkle development process that yeah, there's plenty of time to handle that. Okay, let's move to PeerDAS. So yeah, I think there's a couple of things here. We do have some time left on the call. Okay, good. So let's see. Yeah, first, I don't know if anyone here has been working on the PeerDAS devnets. If someone has and give a small update, that would be very helpful. The last time I looked, there were devnets, but they had a number of bugs, and generally, yeah, the network was not stable. Does anyone have any later information on that work?
So I talked to Jimmy from our team, and he said on the last breakout call, people decided to focus on just like fixing existing bugs and stabilizing clients as opposed to like focusing on another testnet, for example. So I think there's like a testnet delay while things stabilize in clients.
Yeah, that makes sense.
Yeah, I was also on the breakout call, and I think we also discussed that maybe we want a more cleaner spec in the sense, for example, we would want a metadata PR that is out there to be included in the next devnet so that we can have a devnet which has sort of it's all moving parts together rather than missing data where we assume something and then we don't have a very good pairing. So I think, yeah, so for now, we also want to focus to get the spec right and to sort of make sure that we have everything that is required to have a very stable network.
Yeah, certainly. Right. And so kind of on this note, taking that all into account, and again, myself and, others in the chat here, like there's very broad support for PeerDOS as soon as possible. As soon as possible here means in Pectra. So the question then becomes, can we ship PeerDOS in Pectra? If it becomes the case, right, that there's difficulty with PeerDOS is specified, I did want to bring up an alternative in terms of simplifying the initial PeerDOS rollout. So this would kind of be like, let's say like a modification to the roadmap, so to speak. I'm talking with Francesco and a few others, and I think we've at least identified another path. And so yeah, let me summarize that. So with Pectra, with PeerDOS, there are kind of three like core functions that the client performs, right? So the first one would be distribution. So that's taking, at the very beginning, you have a block with many blobs. The blobs get split up in these columns. The columns then are gossiped in PeerDOS. This is the distribution phase. There's next then a sampling phase where you then in turn ask your peers for these samples. That then gives you sort of your availability, sort of, evaluation or assessment of a given set of blobs. Then this third part of the pipeline is reconstruction, which is required in the event that there was some issue with distribution or sampling. So right now, the way PeerDOS is specified in Pectra is that it's essentially doing all three of these tasks: distribution, sampling, and reconstruction. And my intuition is that this middle part sampling is going to be where most of the complexity is. It might even be good to hear on this call if clients think otherwise. But essentially, the suggestion would be to drop sampling from the initial PeerDOS rollout. This should essentially, I think there will be a few other parameter changes to maintain the same security level, but it would be possible to essentially just have the distribution phase along with reconstruction, and then we could drop sampling. And the idea here is that if sampling does become this sort of, hairy implementation concern, then we can get to a place where we could, very realistically consider increasing blob counts with this reduced or like modified PeerDOS scope in Pectra. Okay, that was a lot. Do any clients have any takes so far, or can I clarify something from what I just said? Any responses? Oh yeah, could you hear?
Yeah, I think that is a good thing that we can basically later on add sampling or basically we can also initially launch with having full custody of all the data columns because the blob count has not increased and so there is not much data and bandwidth blow up anyway. Also, what I wanted to add was that the PR in which we are able to the CL can specify the blob target or blob count. I think we should also get that PR in Pectra if it's not already in the scope, and we should basically include it in specs and in devnets.
Right. And so I think the actual numbers would be somewhat dependent on what PeerDOS looks like. But yeah, I agree. That's a good point. And yeah, I think it's time to, do that very soon. Right. And yeah, something that I think would be helpful. There's a question in the chat, just yeah, essentially asking for a written down version of what I just said. I'm happy to put something together, and I can elaborate a bit more and make this more of a proper proposal for consideration. Essentially, this would just be a way to hedge, like again, like development uncertainty of PeerDOS. It could be the case that we do PeerDOS as specified, and it's all in time for Pectra, and everything's good. This is just an option worth considering, especially if we feel like the PeerDOS implementation is not moving along as far or as quickly as we wanted to. So yeah, something to get on the radar now.
Just want to bring up, I think a while back we were still considering PureDOS might maybe make it in before Electra, and that was maybe why we decided not to rebase it on top of the Electra specs, but I don't remember if that was the reason. Because I think that's something that just
Yeah,
get done.
that I think was, I mean, yeah, so that's a slightly different thing, but essentially that was to just simplify development. If Electra is a moving target, then it makes it harder to then rebase PureDOS on top, which is moving target. So they were left separate. For example, for the devnets that we've had so far, we will at some point need to, yeah, put PureDOS into Electra proper. To that, I would just point to the previous conversation around, again, it's the sooner that we can finalize, really, the sooner we can finalize the Pectroscope that we have, the better. At least if only to unblock PeerDOS, which again is, I think everyone agrees, an incredibly important target to aim for. Eton?
And we also need Pectra devnets running smoothly without any forks before we decide to rebase, because then the debugging for PLS would become difficult.
Right.
For PeerDOS, they like the current design. I think still has this special activation epoch, like to make it appear as not a fork. If PeerDOS is actually enabled on Electra, like at the same fork epoch, it also allows me to like make the stable container PR even more simpler, because right now a lot of the changes in there are because the blob sidecars need to be updated because the beacon block body gets re-indexed. And if PeerDOS activates on Electra, there is no more blob sidecar, right? So that the inclusion proof doesn't break. So it's if we can align it, it makes it more simple as well.
Okay, yeah, I mean, that's good to hear. Right. So then, yeah, I mean, maybe we go ahead then and well, yeah, there is a bit of a chicken and egg here. But yeah, because essentially we want to have like enough confidence in PureDOS that we can then put it on top of Electra, but we also want Electra to be stable enough to do that. So that was kind of the issue, and that was also why we had this sort of special epoch activation idea. But yeah, I mean, if everyone's on board, then yeah, let's go ahead and just go for Electra and move from there. Does anyone feel opposed to moving ahead with that right now?
Would this mean we do combined PRDOS Electra devnets in the future, or do we just want to activate on Electra fork epoch but keep like the branches used, etc. separate?
Yeah, that's a good question. I mean, I think the simplest thing would imply yes, it's all together now.
Considering we haven't had any stable devnets on anything, I think this is going to be really, really hard to debug.
Acknowledged. So then maybe this is a little premature, and yeah, we should just focus on DevNet 1.
If it's just about activation, I'm on board. We've also done this in the past. I think for certain features, we've had like Electra devnet as the activation epoch. We just keep them as separate devnet cycles. For example, a 7702 bug shouldn't then lead to all CL devs having to debug what happened to their network, right? So we can still keep the tests separate. We can just change how the features are activated, I guess, or how they're interpreted by the client.
Right.
We had some discussion.
The current issue. Oh, go ahead.
Go ahead. Okay.
Okay.
Go ahead.
The current issue, the current issue here with the fork schedule, one of them is that it redefines deneb. Like, so I understand that some CLs apparently are treating this as a flag, a feature flag of some sort, or I'm not sure precisely what the code structure here is. But in Nimbus, we tend to refrain from these for any longer term usage. And the result is that the fact that this has to activate in deneb, this is how the devnets are defined right now, means that we cannot incrementally merge this. And so I would actually say this this tension that that's being brought up about, okay, well, we can have for testing purposes, separate devnets, there's combined devnet, and the separate devnet though is that the separate devnets also create this artificial breakage, and it is breakage. That is a broken fork schedule. I'm sorry, but that it just is that breakage in the fork schedule is sort of hinders that testing in certain ways, and it means that even if, let's say, 2 or 3 months from now, we all agree, yeah, PureDOS is great, move forward as quickly as possible. But now it has had to, at least in Nimbus, stay outside of that main development trunk because of this broken fork schedule. Because we cannot risk redefining deneb, the production fork, for this purpose, to have columns. Like, that's a non-starter. So so I would say it's actually more effective and more efficient for testing as well overall at some point to combine the two. So this is my claim.
Yeah, I agree as well that it should be combined. My question is just when we do that. If it's more advantageous to do it right now, sure. If there's still open questions, for example, deciding some parameters that PureDAS still needs to, or some parameters that we think PureDAS might still change by, then we could wait until those are changed and then merge it through. But if it feels like it's stable enough, then yeah, I'm on board for doing it earlier.
In a previous call, we discussed having like a PureDAS epoch type parameter, and I think we've got a PR for that. I'm not exactly sure if the current devnets are just doing PureDAS from Genesis or how it's being done currently, but I don't think that was ever decided either. And that, I mean, having a PureDAS epoch is one way to avoid that issue of not being able to having the test get in the way of each other.
So I'm skeptical of the idea of the separate epoch overall, but I agree that for testing it's maybe plausible. However, I would say in terms of isolating things, it would at least be possible to separate out the fork epoch so that it starts at in Electra. Like, so there's sort of separate things here. One is there a delay in terms of I guess is my question, right? So when you're saying like this sort of activation epoch, one is sort of activating at deneb or Electra or sort of far future epoch as a pure testing thing, and another is that people were seriously considering, at least some weeks ago, well, maybe we'll activate PureDOS 50 epochs after Electra starts. So the first, I think, is just a testing concern, and we can work with that. The second, I think, is doesn't make any sense.
Okay. That's helpful. So one other point that was brought up in the chat is essentially that I think many of the PeerDOS implementers are not here right now. There is an implementation call that they have. This is probably, or rather, that's probably the right forum to get into this further. We are also almost at time on this call. So, yeah, again, I would suggest let's focus our attention on the devnets for Pectra. And yeah, it sounds like we're going to need a little more discussion around exactly how to move forward on this issue. It sounds like if we have, if we get a very stable Pectra devnet going, then I think that simplifies a lot of the decision around, yeah, do we rebase PeerDOS on Electra and, get rid of this activation epoch and all of these types of things. Yeah, Perry's asking like schedule it during the PeerDOS breakout. That's the idea. Okay. We just have a few minutes. Let's see. I think Daplion had one last minute thing. Let's take a look. Beacon blocks by range V3. Here's a link to the PR. Is Daplion on the call?
Yeah, I'm here.
Oh, great. Oh, there you are. Cool. Yeah, would you like to give us an overview?
Yes. Very quickly, there is an issue with the current RPC if you want to sync a situation where you want to pull a long fork of blocks from which you don't know which peers consider them canonical or not. The current blocks by range route is spec'd in a way that you just submit a range of slots and the node will provide whatever the node considers canonical. You can query that information with a status message, but that there is some asynchrony on getting those status messages, and it forces you to basically pull this status message every time you want to do the request if you want to be sure that you're pulling the right branch. This has not been an issue because we haven't had like crazy forking on mainnet, but if shit hit the fan, this could be an issue. So what blocks by range v3 introduces is changing the request from just, hey, peer, give me range of slots to, hey, peer, give me a range of slots on this specific branch that may be your head or may not be your head. In my opinion, that makes it much more resilient to the types of sync that we are implementing in Lighthouse at the moment for these very forky situations. And yeah, I think it's a no-brainer. I'm not sure why this was not introduced at the very beginning, and I don't see much downsides. I'm just curious for comment if other clients have specific ways to handle syncing long forks that may not be canonical. Otherwise, this route would be a good addition. Like as a caveat, something that you could do now is use the blocks by root. But with blocks by root, you are forced to do reverse sync. And that's really easy to be attacked because you cannot verify a chain of blocks that you backward sync until it gets rooted somewhere. And that chain can be very long. So a peer can just give you garbage and DOS you. So you need to forward sync somehow. That's why this route. So yeah, if you can check out the PR, let me know if it makes sense. I think the implementation should be simple. So maybe we can target Electra. It's not terribly urgent, but it would be nice. That's all.
Thanks. Yeah, I haven't had a chance to look at this yet myself. But yeah, thanks for bringing it up. And yeah, please everyone take a look. Okay. We're almost at time, and I think that was essentially, yeah, it looks like that was everything on the agenda. Any closing questions, comments, remarks to wrap up the call? Okay, then let's call it. Thanks, everyone. I'll see you on the next one.
Thanks,
Bye.
everyone. Bye.